Thank you, everyone. So I want to start, before I get into the science and everything that I have planned, I just want to start by talking a bit about myself. Because I was in your shoes a long time ago. I was a high schooler here in Ottawa. I went to St. Pius, and I didn't know what I wanted to do in the future. I wasn't one of those kids that knew from, you know, 5th grade that they wanted to be a doctor or a lawyer or anything like that. I didn't know. I knew I enjoyed things like science. I liked science class. I liked doing experiments. But I didn't really know what I was going to do. And that continued even through university. I went to university at Carleton. Actually, I'm a Carleton employee, and I'm also a Carleton product, I guess. I went to Carleton. I studied chemistry because I liked chemistry the best out of all my science courses in high school. And I enjoyed what I was doing in the lab, and it wasn't until about 3rd year that I got a chance to work in a research lab over the summer that I found that I really enjoyed doing research. Even after that, I didn't know what I was going to do with that revelation. I wanted to do research, but what does that mean? And it was only after continuing, I ended up doing my PhD in chemistry, and I did research in the States for a couple of years, that I realized that what I wanted to do was be a professor. I wanted to do research in a lab, but I also wanted to teach. So that's what I do now. I do these sorts of lectures for people like you. I teach university students different classes, and I also do research in my own lab. So today what I'm going to talk about is the field, which is called DNA nanotechnology. And at the end I'll talk a little bit about the work that I actually do, but mostly it'll be kind of a learning experience for all of you guys to find out what is going on in this field, what is DNA nanotechnology all about. So I'm assuming that everybody knows what DNA is. You're here on Biotechnology Day. I'm sure you know what DNA is. But how many people have heard of the word nanotechnology before? You can raise your hand. So I would say maybe 80% of you have your hands up right now. So I'm going to talk about nanotechnology, what it is, and how we can use DNA as one of the tools for building nanotechnology. So today, there's a few things that I hope to cover. I hope to teach you guys a little bit more about what is nanotechnology. Then I want to look at how can DNA, which we know to be involved in genetics, if it's the molecule of life, how can we use DNA in this very synthetic world of nanotechnology? And then I'm going to look into my crystal ball, and I'm going to answer a question that I ask a lot. DNA nanotechnology safe? Should we be doing DNA nanotechnology at all? Okay, so what is nanotechnology? You've heard of the term nano. You may have heard it in terms of your iPod. You may have heard it in terms of the smart car. They call it the nano car. But nano, what does nano mean? Nano is really just a prefix. It means 10 to the minus 9, or a billionth. So when I say a nanosecond, I mean 1/1000th of a second. Or if I say a nanometer, that's 1/1000th of a meter. So really tiny. Tens of thousands of nanometers in a diameter of your hair. So really a small size, a small length. So nanotechnology and nanoscience are the study and the manipulation of things on that scale. So new materials, new devices, new machines that we're trying to make that are on the length scale of less than about 100 nanometers. Why are we interested in that? Because at that length scale, things change. Things are different when they're nano sized. They might be lighter, they might be stronger, they might be easier to use, they might be more flexible. So we want to use things that are nano for new purposes, new devices, new technology. But I'm saying new. The truth is that nanotechnology is actually old. As early as 500 AD, artisans were using gold nanoparticles in stained glass windows. So here's an example of a stained glass window with a lot of red. That red color is actually coming from gold nanoparticles. They didn't know they were using gold nanoparticles. All they knew is that when they prepared their paint a certain way, they got this beautiful red color that was really robust and lasted a long time. So they used it for their stained glass windows. Now we know that those are nanoparticles, but they didn't know that. So nanotechnology is actually really old, but what is new is that we can understand it now. We can see nanoparticles now because we have the machines. We can control nanotechnology now because we have the knowledge. So what I have here is a picture of something called an atomic force microscope. I'm going to be showing you lots of pictures today, and those pictures are microscope images, but special microscope images. Even our regular microscopes can't see things that are a nanometer. So this type of microscope can. The way it works is it has this tip that you can drag across a surface, and it can move up and down on such a small scale, and it can measure nano bumps and nano grooves and everything. And then that is going to get converted into an image so that we can actually see the nanoparticles or the nanotubes or whatever it is that we're working with. So with that knowledge, we have control. And with the control, we can build functional things. We can build machines. We can build devices. So let's look then at what modern nanotechnology is all about, right? Modern nanotechnology is all about controlling things and making shapes. Here are some examples of synthetic nanotechnology, not DNA, just synthetic stuff. So things like buckyballs or fullerene are made of carbon. There's carbon nanotubes, nanowires made of zinc, gold spheres, particles, other types of crystal shapes, rods, empty tubes. All these things are possible, and we can control them. We can take those carbon buckyballs and make them into a line. We can turn that into a wire. So these sorts of things are what's on the cutting edge of nanotechnology, being able to control these small sized particles and do useful things with them, like make wires, make chips, make that sort of thing. But how does DNA fit into all of this? We know that DNA is something natural, right? It's a natural material. So that's why I wanted to show you this graph or this plot. You have this arrow. As you go down the arrow, you see milli, so the millimeter length scale, down to the micrometer length scale, down to the nanometer length scale. And there are pictures on either side. On one side you have all synthetic things, and on the other side you have natural things. And I want you to compare on the different length scales, what exists, what's possible. If we look on the synthetic side, on the millimeter length scale you have a pin. The head of a pin is maybe a millimeter. It's hard to see, but if we put it under a microscope it would be easy to see. You can make a millimeter size object without too much trouble. The equipment's not that expensive. As you go down on the synthetic side, things are getting harder to see, harder to make. The next set of pictures are something called microelectromechanical devices. They're gears and machines and devices that are on the micrometer length scale. It's a little bit harder to make these. You need more expensive equipment. You need better microscopes to see them. So it's getting harder and harder as we're going down. On the nano side, in terms of synthesis, the buckyball nanotube, these things are useful. We can put them in devices, but they're harder to make and they're much harder to see. So what I want you to notice is as we go down that length scale, things are getting tougher and tougher and tougher on the synthetic side. How about the natural side? If we look at the natural side and we're going down the length scale, everything is still, relatively understood. Okay, so if we go down, we have ants. Okay, millimeter, I can see an ant. Doesn't take much for me to see an ant. If I go a little bit further, I have things like my hair. That's micrometer. Okay, a natural system that's assembled on its own, right, coming out of my head, that's fine. Go a little bit further and there's blood cells. I may not see blood cells very well. I might need a microscope or something to see them, but they work very well as oxygen carrying machines without any intervention on my part. Go a little bit further and we have DNA and proteins. We can think of them as nanoscale natural machines that have jobs in our bodies or in nature, and they're doing their thing without any intervention on our part. So what I want you to kind of contrast here is synthetic nanotechnology can be very difficult, but nature is doing nanotechnology all around us. Maybe we can look at nature and get some ideas on how to do nanotechnology more efficiently, more simply, get some precedent from them.